Okay, so when we talk about the equivalent mass or equivalent weight, earlier it was called equivalent weight, now we call it equivalent mass. The equivalent mass of a substance is defined as the number of parts by mass of a substance which combines with or displaces directly or indirectly. Means we are just talking about the reaction. And in that reaction, we are talking about the mass of that substance which combines or displaces directly or indirectly what? 3 points we will be talking about. 1.008 parts by mass of hydrogen. Everything we are talking in terms of mass. We normally take it 1 part by mass instead of 1.008. So in numericals, which we will be doing, we will be using 1, not 1.008. Or 8 parts by mass of oxygen. 8 parts, okay? Or 35.5 parts by mass of chlorine. This is the definition of equivalent mass, and we will be using this. Okay, 1 part by mass of hydrogen. So suppose I have A and it reacts with hydrogen and gives C and D. So suppose it is given that 40 grams of A reacts with 8 grams of hydrogen and gives something. So what we will do, we will just downgrade it to 1 gram hydrogen. And with that, we will do the unitary method that it will be 5 grams. So this will be the atomic mass of A. So how you got 1? You divided 8 by 8, you got 1. Here also you divided 40 by 8, you got 5. So whatever is equivalent to 1 gram of hydrogen will be the atomic mass. Similarly, in different reaction, it can be that A and B react and they produce C plus hydrogen. And say 30 grams of B displaces hydrogen from A, okay, and that is equal to 6 grams. So we will say what is the uh, atomic mass, sorry, equivalent mass of hydrogen. So we will again divide it by 6 to have it 1 gram, 30 divided by 6, 5 grams. So whether it is combining or whether it is being displaced, we will compare the mass of the compound which combines or displaces 1 gram of hydrogen, or in place of hydrogen, if I have oxygen, then that will I will consider 8 gram. If I have chlorine, I will consider 35.5 gram. Is this clear about equivalent mass? Okay, because it is
Yes,
slightly
sir.
difficult than molar mass. Okay, slightly. Molar mass is straightforward because that will not change depending on the reaction, but equivalent mass will change depending on the reaction. So that is the major difference you will see. Equivalent mass is not same. So we will be talking about equivalent mass of a particular reaction. So if valency are different, and rule is very simple, okay? If a compound, an element in a compound can show different valencies, then it can have different equivalent masses. Example, the following examples clearly illustrate the definition of equivalent mass, okay? 2 parts by mass of hydrogen combines with 71 parts by mass of chlorine. It means here 2 grams of hydrogen combines 2 into 35.5, that is 71 grams of chlorine. Or 1 part by mass of hydrogen will combine 35.5 parts by mass of chlorine. So in this case, the equivalent mass of chlorine is 35.5. So see here we are comparing even chlorine with hydrogen. However, chlorine is also under the definition. So if you see, I'm going back, 35.5 parts of chlorine. So suppose I have another reaction, A plus Cl2 gives you C plus D. Okay. And say 142 grams of A combines with 71 grams of chlorine. So in that case, to calculate the equivalent mass of A, we will bring it to 35.5. How we do that? 71 divided by 2, 35.5. And here also we will divide 142 by 2. We will get 71. So it means the equivalent mass of A will be 71. If it would have been 200, atomic mass of it would have been 100. So equivalent to 35.5, whatever mass we get, that is equivalent mass. Here in this case, we have hydrogen and chlorine, and we can take hydrogen as the base point. So if hydrogen is the base point, we will compare 1 gram of hydrogen, and whatever mass of chlorine we get, that will be equivalent mass of chlorine. That's what we have done. Next one, magnesium burns in oxygen gas to form magnesium oxide. Now here, what is the reference point? Oxygen. So as per definition, we will use oxygen here. As per this reaction, 2 into 24, that is 48 grams oxygen reacts with 32 grams. But we need to downgrade it to 8. So we downscale it to 8 grams because that is the definition. That whatever amount reacts with 8 gram of oxygen, 8 parts of oxygen, that mass will be equivalent mass of magnesium. So we divide 32 by 4 to get 8. Here also 2 into 24 we will divide by 4 to get the equivalent mass. It means it will be 12 grams. So equivalent mass of magnesium in this case will be 12 grams. 12 parts by mass, that is 12 grams. So when I am saying gram, I am talking about gram per equivalent, and equivalent I will be talking about later. Okay. Otherwise, you see, we are talking about 12 parts by mass. 12 parts by mass means if it is in gram, it is gram. If it is in kilograms, it's kilogram. But normally we will use grams here. Next example, zinc reacts with sulfuric acid. Now, in this case, you don't have anything on the reactant side. Hydrogen, oxygen, chlorine, you have to compare either with hydrogen or with oxygen or with chlorine. But in this case, hydrogen is evolved. And that is the definition, either combines or displaces. So you will use this part here. To get this part, you will again apply, and you can use for both, whether you want to get the equivalent mass of zinc. For that, you will compare these two. If you want to calculate the equivalent mass of H2SO4, you will compare these two. In both cases, you are comparing with hydrogen. But hydrogen should be 1. Here it is 2. It means 65 divided by 2, that is 32.5 grams of zinc will combine with 1 gram of hydrogen. So this will be the equivalent mass of zinc. Similarly, if I compare this relationship to calculate the equivalent mass of H2SO4, for 1 gram, 98 divided by 2, that is 49 will be there. So 49 will be the equivalent mass of H2SO4 from this reaction. Any confusion, let me know. Definition is very simple. You have to compare the mass of the compound, which is equivalent to either 1 gram of hydrogen or 8 grams of oxygen or 35.5 grams of chlorine. These three can be either on the left hand side or on the right hand side. Okay, you can use anywhere. If it is on the left hand side, it means these are reacting. If these are on right hand side, means these parts are liberated. So 32.5 parts zinc atomic mass. And if you use the same for H2SO4, 49 parts will combine with 1 gram of hydrogen. So 49 will be atomic mass of H2SO4. Equivalent mass, not atomic mass. Okay. Now, equivalent mass can also be calculated from the formula of a compound. But in this case, whatever we consider the valency of the element, most probably the metal, that will decide the equivalent mass. Okay. AlCl3. So aluminum chloride, how many chlorine atoms are there? 3. So you will say 3 into 35.5 parts by mass of chlorine combines with 27 parts of aluminum, because atomic mass of aluminum is 27. So aluminum is just one. So 1 mole will be 27 parts. Hence 35.5 parts will combine with how much? Because chlorine definition is 35.5 parts. So we will calculate it. It will be 27 by 3. That is 9. We applied unitary method. So 9 will be the atomic mass of aluminum in aluminum chloride. Equivalent mass of aluminum in AlCl3 will be 9. Similarly, in FeO, oxygen reference point is 8 parts. So in this case, if you see 16 parts, because atomic mass of oxygen is 16, okay, and iron 56. So 16 parts of oxygen combined with 56 parts of iron. So 8 parts of oxygen will combine with 28. It means 28 will be the equivalent mass of FeO. Next one is gram equivalent mass. Gram equivalent mass is same thing what we have, similar thing what we have talked about in case of mole. When we say molar mass and gram molecular mass. So when we say gram molecular mass means 1 mole. Okay. Here also similar thing. The mass of a substance in grams, which is numerically equal to its equivalent mass, is called gram equivalent mass. So if I am saying that equivalent mass is 27, then 27 gram is actually gram equivalent mass. Similar to the molar mass, when we say we have 1 mole, okay, so molecular mass, if molecular mass was 56, then molar mass was 56 grams per mole, or gram molar mass was 56 grams. Gram molar mass means mass of 1 mole. Similarly here, mass of 1 equivalent, that's it, we get it in grams. So same thing, equivalent mass when we represent in grams. So equivalent mass when we represent in grams, we call it gram equivalent mass. So how we can get gram equivalents from it? Gram equivalents will be whatever mass we have divided by equivalent mass. Same thing, gram equivalent is same thing as number of moles. Okay, so number of moles we calculated given mass divided by molar mass. Here also the same thing. This is given mass divided by equivalent mass. Same thing. And equivalent mass, you know how to calculate, different ways we have talked about. Any confusion here in this case? Make sure that you are attentive. Otherwise, when I do the numericals, you will face problem. You will get confused. Now, equivalent mass in terms of valency. In few questions, you will be asked to calculate equivalent mass. And obviously, it will be not the straightforward question. Rather, you will be required to calculate equivalent mass as an intermediate part. Okay? So in terms of valency, also you can calculate, and the formula is straightforward. And in this case, depending on the valency is variable, equivalent mass be different. So valency is 2, it will be different. Valency is 3, it will be different, because the formula for equivalent mass in terms of valency is atomic mass divided by valency. Okay. Now I'm going back just to tell you that when we calculated the equivalent mass of AlCl3, and aluminum always has valency 3, right? So that's why you actually applied this formula there, atomic mass divided by valency. So here, if you see in this case, what you did to calculate the equivalent mass of aluminum, atomic mass of aluminum is 27 divided by its valency is 3, you got 9. Although here you got it by the definition that how much mass of aluminum will be equivalent to 35.5 grams of chlorine. Okay. But you could have got the equivalent mass by using this formula also. This one, atomic mass divided by valency. Keep writing all these formulas, because all these formulas, depending on the situation, will be used. Depending on what data is given in the question, you will be using different formulas. So since atomic mass of an element is always constant, but its valency may change in different compounds, therefore its equivalent mass changes with change in valency in its compound. Equivalent mass of an acid. For calculation of equivalent mass of an acid, first we need to understand what is basicity. Okay. So the number of hydrogen ions that one molecule of an acid can give in its aqueous solution is called its basicity. It is not called acidity. It is called basicity, and the reason is, suppose I am talking about HCl. HCl gives us one H plus and one Cl minus. So it gives one proton, one hydrogen ion. It means its basicity is one. Why? Because this will neutralize one base. Will neutralize one molecule of a base, or you can say will neutralize one OH ion. So it will neutralize one base. So that's why basicity is 1. This is called basicity. It means equivalent mass of an acid is its molar mass divided by basicity. And basicity is what? How many H plus ions it gives in its aqueous solution. So for example, if I am talking about H2SO4, most of the times H2SO4 will show the basicity as 2 because it will give 2 hydrogen ions. But many a times it will show basicity as 1 also, okay, depending on the reactions. Again, write down the formula. Equivalent mass of an acid is molecular mass divided by basicity. So here HCl gives H plus Cl minus, basicity 1. So in this case, equivalent mass of HCl will be its molecular mass divided by basicity, that is 36.5 is molecular mass of HCl divided by 1 basicity. So equivalent mass and molar mass same in this case. But if I am talking about H2SO4, H2SO4 basicity is 2. So in this case, equivalent mass in this particular reaction, okay, it is molecular mass divided by basicity, 98 divided by 2, that is 49. So you can get equivalent mass based on how many hydrogen ions it is releasing. All these formulas are actually interrelated. Okay. I'm going back when I talked about the example zinc reacts with H2SO4. There actually why its equivalent mass is 49. The reason is very simple, because it is giving 2 hydrogen ions there. Okay. So if you see that part again, this one, H2SO4 gives 2H plus, okay, that actually gives you H2. So that's why the equivalent mass is 98 divided by 2. All are interrelated. H3PO4, it gives 3H plus ions. Because it gives 3H plus ions, basicity is 3. Then in this case, its molecular mass is also almost 98. Okay, not exactly 98, but almost. So both H2SO4 and H3PO4 have molecular mass 98. But here I will divide it by 3, so it will be 32.67. Current mass will be 32.67 here. Similarly, equivalent mass of a base, similar to acid, bases will have acidity depending on how many OH ions these give. Okay, we will calculate the equivalent mass of a base. Now, slight important point here. Okay, if I am talking about OH minus and one OH minus, okay, I will have to consider 17 parts. And why 17 parts I have to consider? Because it is actually 16 plus 1. oxygen 16, hydrogen 1. So I am reading the definition. Okay, equivalent mass of a base is the number of parts by mass of it which can neutralize one equivalent of an acid, or it is the number of parts by mass of it which can furnish one equivalent or 17 parts by mass of OH minus ions in an aqueous solution. 17 parts by mass. Why? Because OH minus, the molar mass, if you consider, will be 16 plus 1, that is 17 gram. So the number of OH minus ions that one molecule of a base can give in its aqueous solution is called its acidity, and the formula is similar here. Equivalent mass of a base is molecular mass divided by acidity, and acidity is nothing but how many OH ions it gives. So example, caustic soda gives you 1 OH minus. It means its acidity is 1.
Sir,
Yes.
sir, could you please show the previous slide?
Yes.
Okay, sir, thank you.
Acidity is 1, and we apply the formula. Equivalent mass equals to molecular mass divided by acidity. Molecular mass is 40, 23 plus 16 plus 1 divided by 1. So same. Equivalent mass and molecular mass same. Now if we talk about calcium hydroxide gives you 2 hydroxyl ions. It means its acidity is 2. So you will divide the molecular mass of calcium hydroxide by 2 to get equivalent mass. So equivalent mass will be molecular mass 74. You will get 74 as 40 plus twice of 16 plus 1 divided by 2, that is 37. So these simple concepts are used extensively in these type of questions. And if you don't know, then it is tough. If you know it, it's easy. Similarly, aluminum hydroxide. Okay. Okay, just a second. Karthikeya, is this clear now?
Yes, sir.
Okay. Now, aluminum hydroxide will give you 3 hydroxyl ions. So acidity is 3. Divide the molecular mass of aluminum hydroxide by 3. 78 divided by 3, 26 is the equivalent mass of aluminum hydroxide. So effectively what you are saying that equivalent mass is less than equal to molecular mass. Equivalent mass is less than equal to molecular mass. It cannot be greater than molecular mass. And this helps you sometimes to strike off few options out of 4 in JEE, and you can narrow down your answer, maybe to 2, and then you will save time. So sometimes just simple concepts help you. If any option has equivalent mass greater than molecular mass, that cannot be the answer. Next, equivalent mass of a salt. In the case of salt, mass of it which contains one equivalent mass of the metal, because all the salts will have metal. So that's why the definition includes metal. One equivalent mass of metal will decide the one equivalent of the salt. How? Equivalent mass of a salt, total valency of a metal is equal to valency of the metal ion multiplied by the number of atoms present in the formula of the salt. I'll show you a diagram, okay, a chart, just to understand what I'm talking about. Okay, in the formula, one point is very important which you need to remember. It is total valency, and total valency, what it is, I'm going to explain. Okay, equivalent mass of a salt is molecular mass, so this is same, numerator is same, divided by total valency of the metal in the salt. Now understand what we are talking about, total valency. Okay, from the first, second, third, etc., you might not understand what is the difference, but understand here. Mm, in these two. Okay, in this one is simple because valency of the metal is one, number of metals only one, but here valency of potassium is one, but how many potassium are there? Two. So you will multiply these two, this will be the total valency. Understand this one, last one, Al2SO4 whole thrice. What is the valency of metal? 3, but how many atoms are there? 2. So total valency will be 6. So we will not write just the valency of the metal. We will write the total valency, and total valency simply is the valency of one atom multiplied by how many atoms are there. That's it. Okay. And only metal we will consider. We are not considering anything else. We are considering only metal. So total valency of the metal in the salt will be in the denominator. Next one, equivalent mass of an ion. Very simple one. Again, molecular mass. Molecular mass is written as formula mass if we are talking about ionic compounds. So formula mass divided by charge on the ion. Example, if we are talking about sulfate ion, we will write the formula mass of the ion divided by charge, which is 2. So 96 divided by 2. How we got 96? Don't calculate SO4 2 minus. You know that H2SO4 is 98. So SO4 2 minus will be just deduct 2 from it. These H2 gone. Divided by the charge, that is 2, you got 48. Next, equivalent mass of oxidizing and reducing agents. A given substance may have different equivalent masses in various reactions, depending on, as I said, that what oxidation state it is showing there, okay, which is something similar to we have talked about the valency. Okay, so in a simple way, the equivalent mass of an oxidizing agent is calculated from the number of oxygen atoms it produces. Number of oxygen atom it produces. So we will be doing a few, I will be showing example so that you can understand just in a few seconds. And equivalent mass of a reducing agent means it will get oxidized. Oxidizing agent gets reduced, reducing agent gets oxidized. So the equivalent mass of a reducing agent is calculated from the number of oxygen atoms with which it combines. It means if the reaction is something like that, A plus B gives you C plus O2. So oxygen atoms being produced means here we will be talking in terms of oxidizing agent. Okay. And if it is something like A plus O2 gives you C plus D, it means here it is combining. So in such reactions, you will be asked to calculate equivalent mass of the reducing agent. Reducing agent gets oxidized, and oxidation is addition of oxygen in a compound. Addition of oxygen in a compound is oxidation. It means this is reducing agent. For example, equivalent mass of KMnO4 in this reaction. Now in this reaction, 5 oxygen atoms are being released, liberated. Liberated means it is not combining, these are being produced. So KMnO4 is oxidizing agent, and KMnO4 is indeed strong oxidizing agent. We will be using it quite frequently in organic chemistry for oxidation. KMnO4 extensively used for oxidation in organic chemistry. And now we will apply the same definition what we have already studied. We will calculate how many grams of KMnO4. So depending on the balanced reaction, we will calculate the molar mass. We will multiply it by 316 grams, or you can say 316 parts by mass. Liberate 5 into 16 parts by mass of oxygen. But what is the definition? Tell me, what is the definition to get the equivalent mass? Raise your hand. Who will tell me what is the definition you can apply here to get the equivalent mass? The definition we have already talked about today. Which definition we will apply here? Raise your hand. Think about all the definitions we have talked about. Okay. Yes, Arjun. Which definition we will apply here?
So like equivalent mass, it is a number of parts by mass by which a substance displaces 8 parts by mass of oxygen, 35.5 parts by mass of chlorine, and 1 parts by mass of hydrogen.
Right.
So
Which,
we
which
will,
one? Yes. Yes, continue.
sir, so we will apply unitary method at sir, 5 into 16 parts by mass of oxygen is like produced by 316 parts by mass of KMnO4. So 16 parts by mass will produce by how much KMnO4?
Basically, you told me everything correct, even the definition correct. Only in the last step, it's not correct. Okay. Otherwise, everything is correct. Good. Shashwat, do you want to say something?
So I was saying the same thing.
In the last step, you said 16 part, it will be 8 part of oxygen. The definition says 8 part of oxygen, not 16.
Yes, sir, 8 parts.
Okay. So that was the only correction required. Otherwise, good. Very good. So here you see that uh, how many parts we are talking about. 5 into 16 parts, okay, by mass of oxygen are liberated from 316 parts. So 8 parts of oxygen are liberated by how much? We will apply unitary method. That will be the equivalent mass of KMnO4. So you just applied the concept that if it is being liberated, then we are talking about in terms of it is oxidizing agent. Okay, it is getting reduced. KMnO4, it is oxidizing agent. This concept will be used, right? That's why I have told you. Otherwise, you are just applying the simple definition. How many parts will liberate? 8 parts of oxygen. That's it. Next one, to calculate equivalent mass of K2Cr2O7 in this equation. Again, the same thing. 48 parts are liberated, parts of oxygen are liberated by 294 parts by mass of K2Cr2O7, potassium dichromate. So 8 parts will be liberated by how much? That will be the equivalent mass of potassium dichromate in this reaction. Is this clear? Any problem? Let me know. Good. Equivalent mass of FeSO4 in this reaction. Who will tell me the answer? Just raise your hand. You need to apply the definition and you need to tell me what is the equivalent mass of FeSO4 in this reaction. Only Shashwat has raised hand. Yes, Shashwat.
So here FeSO4 combines with 1 part oxygen.
Hmm.
which is of 16, whose mass is 16 parts. So we'll just divide 304 by 2. So we'll get how much FeSO4 will combine with 8 parts by mass of oxygen.
Good. Very good. So we will calculate how many parts by mass of FeSO4 will combine with 8 parts by mass of oxygen. Good answer. Okay. Shashwat. Arjun
Thank
and Samad, yes. Correct answer. Good. So you will get 152 as equivalent mass. So equivalent mass of Na2S2O3 in the reaction. Again, 16, you will bring it down to, scale it down to 8, and you will get half, 158 parts of by mass of Na2S2O3. Yes, in chat window also I am getting correct answers here. Kartike, yes. Now, these are all the definitions we will be using, and definitions are simple. It's just a matter of fact whether you know these or you don't know these. Otherwise, these are very simple. Next concept, which is related to, and it is used because we will be using molecular mass, we will be using equivalent mass, and sometimes it is not given directly. Okay. So in that case, we use Dulong and Petit law, which says atomic mass into specific heat is equal to 6.4. So sometimes you will have to calculate the atomic mass, exact atomic mass, by using this equation. So write it down. Atomic mass into specific heat is equal to 6.4. Now what is different here? The different thing is that you will not be given exact atomic mass. So I'm going to explain that, how you will get the exact. So this relation can be used to calculate exact atomic mass, as I am going to show you. First, approximate atomic mass may be calculated. How? Approximate atomic mass will be 6.4 divided by specific heat. Specific heat will be given. But you can say that if this relationship is given, then why I am not getting atomic mass? This specific heat is given. I should get the atomic mass directly. The reason is this specific heat itself may not give you the exact atomic mass. Atomic mass will be, 56, 58, 64, like this. So what happens that you calculate valency as approximate atomic mass divided by equivalent mass. Once I explain everything, it will be clear what I am talking about. Okay. Valency cannot be in fraction. Valency will be either 1, either 2, either 3. There might be a case that you get these things just as that you here get exact value 3, okay, or exact value 2. There might be this case. Okay. So it means that a specific heat was given in such a way that you could have calculated atomic mass directly. But a specific heat is not calculated very accurately. So we don't know the exact amount of a specific heat. Okay, and what is a specific heat? We will be talking about in detail in thermodynamics chapter. Here I'm just telling you the definition. A specific heat is that amount of heat which increases the temperature of the substance by 1 degree.
So we've heard about it in physics also.
Good, very good. So specific heat is that amount of heat which increases the temperature of the object by 1 degree. So if the temperature of the object is 40 degree and we provide some heat so that its temperature becomes 41 degrees Celsius, so the difference of energy will be, or the heat provided will be, specific heat. Okay. But sometimes we might not calculate that amount of heat exactly, how much heat we provided. Okay. So that's why we will use that approximate heat here, and we will get approximate atomic mass here. But valency cannot be approximate. Valency will be always a whole number, okay, natural number. So we will divide that approximate atomic mass by equivalent mass. Now the valency is rounded to nearest whole number. So suppose we get valency as 2.9, we will round it off to 3. The moment we got the valency as 3, we can get exact atomic mass as equivalent mass into valency, because we know the formula equivalent mass was equal to atomic mass divided by valency. Do you remember that formula? Equivalent mass equals to atomic mass divided by valency. We used it in, for example, AlCl3. I gave you example. Okay, so equivalent mass was atomic mass 27 divided by valency 3, that is 9. So this formula we can apply to get the atomic mass. So atomic mass will be equal to equivalent mass multiplied by valency. So exact atomic mass can be calculated by Dulong-Petit law. Is that clear or not what I am saying?
Yes, sir.
Okay. So just remember, atomic mass is equal to specific heat. Atomic mass into specific heat is equal to 6.4. This is Dulong and Petit law. They gave it, okay, scientists. And from here we can get approximate atomic mass. Okay. Then this approximate atomic mass we can use to calculate valency. Valency will be approximate atomic mass divided by equivalent mass. And then we will use that valency, rounded off valency, to calculate the exact atomic mass. Now next topic. And next topic is which is something similar to stoichiometry, right? Something similar to, we will make use of stoichiometry here. So eudiometry is what basically, here we have a tube. Okay. Mostly hydrocarbons will be reacted with oxygen, means combustion of hydrocarbons will take place in that tube. How that will take place? We will have some 2 electrodes there. So this is a specific type of tube. I will show you the diagram. First understand it. So this tube will have the hydrocarbon and we will provide plenty of oxygen. Oxygen will not be limited. Excess of oxygen will be provided. And then combustion will be initiated by what? By sparking between the electrodes. So reaction will take place. When hydrocarbon burns, combustion of hydrocarbon gives you carbon dioxide and water. You know the generic equation I have told you, and that generic equation will be used here. Generic equation of combustion of hydrocarbons. Who will tell me? We have talked about it quite a few times in mole concept. Raise your hand. Who remembers the generic equation of combustion of hydrocarbons? CXHY plus some oxygen will give you some carbon dioxide and some water. How many of you remember that? Okay, 3 students have raised hands, Savya, Shashwat and Yash. Okay, Savya, tell me.
So CXHY plus uh, X plus Y by 4 O2 gives X CO2 plus Y by 2 H2.
Good. Very good. So you have to remember that because we will be making use of that. So the combustion takes place around in the eudiometric tube, okay, based on this reaction. And there are few points we are going to talk about. So eudiometry, this method is used for determining the molecular formula or the percentage composition. It is same thing. If you know the molecular formula, suppose you know C2H6, you can calculate the percentage composition as well of a gaseous mixture of hydrocarbons. Okay. So whether it is 1 hydrocarbon or 2, 3 hydrocarbons, it will actually tell you the overall percentage, not of 1 hydrocarbon, overall percentage or the molecular formula of entire mixture. So for example, if it is C2H2 and C2H4, okay, it will not tell you separate formulas, rather it will tell you how much combined carbon is there, how much combined hydrogen is there. Okay. In that case, the apparatus consists of a closed graduated tube open at one end. The closed end is provided with platinum electrodes for passage of electricity through the gas to initiate the reaction. Such tube is called Eudiometer tube. It is filled with mercury and inverted over a trough containing mercury. So this is how it looks. The tube in reality looks like this, the right side. Okay. Left side is diagrammatic representation. And there are a scale, there is a scale for measurement of how much mercury is there and what is the volume of the gas. So these are the electrodes. Why these electrodes are there? Because if we have say C2H6 plus O2, they will not react by themselves. We will create a spark through these electrodes. And this end is closed. The open end is submerged in mercury. Now, how the process happens and what are the steps, I am going to talk about those steps. Method involves following steps. A known volume of gaseous hydrocarbon or gaseous mixture mixed with excess of oxygen. Oxygen must not be in scarcity. It must be in sufficient amount. Whatever is unreacted oxygen, we can get absorbed in pyrogalol. I will tell you later. Okay. So a known volume of hydrocarbons, for example, C2H4, C3H8, etc., is mixed with excess of oxygen or air is introduced in eudiometer tube over mercury. The mixture is exploded. Exploded means by electric spark, reaction takes place, burns, it starts burning. So carbon and hydrogen are oxidized to CO2 and H2. It means, suppose I am talking about CH4, okay, so it will be CO2 plus H2O. Okay. Whatever carbon is there, that will give you CO2. Whatever hydrogen is there, that will give you H2O. It means if you can calculate how much carbon dioxide there, you can calculate carbon into it. The same carbon came from here, so you can calculate the carbon in the hydrocarbon. If you can calculate how much water is there, okay, water vapor, we will condense it. Then you can calculate how much hydrogen is there, and same hydrogen came from here. So means same amount was present in the hydrocarbon. The mixture is then cooled. After the reaction, we will cool the mixture. Why we will cool the mixture? So that the water vapors get condensed to liquid form. So they will not occupy any volume then. Volume of water vapor will become negligible as compared to other gases. So we will have only carbon dioxide and oxygen now. Oxygen means unreacted oxygen. Because when we talked about the reaction, say I am doing the reaction CH4 plus 2O2 gives you CO2 plus 2H2O. But suppose oxygen is in excess, instead of just required 2O2, we have given 6O2. So 2O2 will react and here 4O2 will remain unreacted. 4O2 will remain unreacted. So after that, when combustion has taken place, if we cool down, this will get converted to liquid. Only these two will remain. So it means the remaining volume is only due to CO2 and 4O2. Now we can absorb this CO2 and 4O2 separately. CO2 can be absorbed by KOH and O2 can be absorbed by pyrogalol. I will be showing you, okay, the reactions. So KOH is introduced now in the system, which absorbs carbon dioxide, and only unused O2 is left. Okay, unused O2 is left. I will tell you how this will help you to calculate the amounts. Okay, so this is the reaction which takes place. Normally, you will not get this reaction written wherever eudiometry is explained, but you should remember this is how the carbon dioxide is absorbed by KOH. It will get converted to potassium carbonate. Thus, decrease in volume on adding KOH will be volume of CO2 produced. So remember what I am saying. In this apparatus, after cooling, whatever is the volume here, that volume is due to CO2 and O2, because H2O has been liquefied. After the reaction I am talking about, okay? This is written before the reaction. This is after. After the reaction, there will be carbon dioxide and oxygen. So these, and we will calculate the volume because this tube is graduated. This tells us the volume, how much volume is there. So we got the volume of CO2 and O2. So say the volume was here 60 ml. Then we introduced KOH, and after KOH, the volume is 40 ml. Means 20 ml was carbon dioxide that was absorbed by potassium hydroxide. Whatever is remaining is oxygen. Okay. In few cases, there might be some impurity of other gases also. So in that case, this 40 ml will be O2 and that gas which is present as impurity. So is that clear how we calculated the volume of carbon dioxide produced? We calculated the volume of carbon dioxide produced by first getting the volume to overall volume, and then introducing KOH. KOH will absorb only carbon dioxide. So whatever is the decrease in volume, that will be due to carbon dioxide. We got the volume of carbon dioxide. Difference will be the volume of carbon dioxide. Next, volume of unused O2 can be measured by absorbing. Suppose it is not 100% oxygen. Okay. Suppose it is not 100% oxygen. Then what we will do, we will introduce alkaline solution of pyrogalol. This remaining solution, whatever gases are remaining, those will be introduced in alkaline solution of pyrogalol. And what is pyrogalol? Pyrogalol is this. Benzene ring, okay, phenol has ortho and para alcoholic group also. So there are 3 alcoholic group OH groups on benzene ring adjacent carbons. This is pyrogalol. And specifically JEE, how it reacts, this reaction that normally is not given because it is specific to JEE. Okay, that pyrogalol reacts with oxygen, first gives orthoquinone. Then again it reacts with oxygen and gives 2-pyrone. Specific to JEE, so those looking for JEE should write this reaction. Normally not given in guides, etc. So because whatever oxygen is present, that will react with pyrogalol, that will be absorbed by pyrogalol. So whatever is the decrease now, or whatever is the increase in the mass of solution, known solution of pyrogalol, that is the oxygen, amount of oxygen. Okay, so there are 2 ways to get the amount. Okay, so there are 2 ways, and same applies here also. Whether we say decrease in the volume of adding volume on adding QH is the volume of QH, or you can say you have a known amount of KOH. So if you know how many grams of KOH you had earlier, and once it absorbs CO2, after that what is the mass of the solution? It means the solution absorbed that much carbon dioxide. Understand what I am saying? Okay. Suppose initially the solution was something X plus this known Y. Okay. I am talking about only non-gaseous parts. Okay. Non-gaseous parts. And you introduce Y. After that, this mass is Y plus 20 grams. It means 20 gram was carbon dioxide. So you can get the mass here. Difference in mass will tell you how much carbon dioxide has been absorbed. Same thing here also you can do. How much mass you used of pyrogalol, and after reaction, what is the mass of the mixture? It means it absorbed that much oxygen here. So you got both carbon dioxide and oxygen. Okay, both. Now, just for your knowledge, okay, eudiometry is based on Avogadro law, which states that equal volume of all gases under similar condition of temperature and pressure contain equal number of molecules or moles. So, for example, the classic example N2 plus 3H2 gives you 2NH3. And in terms of volume, we say 1 volume of N2 reacts with 3 volumes of hydrogen gives you 2 volumes of ammonia. Or you say 1 mole reacts with 3 moles of hydrogen gives you 2 moles of ammonia. This is when we are talking about specifically at STP. Otherwise, ratio will be same. It might not be 1 volume exactly, okay, 1 mole exactly. 1 volume might not be equal to 1 mole exactly, but the ratio will be same, 1:3:2. Okay. And that is actually the Avogadro law, which says that equal volumes have equal number of moles. The ratio of equal volumes is ratio of equal moles. The equation for combustion of hydrocarbon, which I asked you, is this one, which you have told me already. Okay. CXHY plus X plus Y by 4O2 will give you X CO2 plus Y by 2 H2O. How we will use it in eudiometry, that's what I'm going to explain. Okay. Before reaction, 1 mole of the hydrocarbon will react with X plus Y. Here we have 1 which is not written. Will react with X plus Y by 4 moles of oxygen. And initially there is no carbon dioxide. But once reaction has happened, then you won't have any moles of hydrocarbon and oxygen. I am considering only out of these. If there is excess, obviously if we have ZO2 excess, so you will have ZO2 excess here. That is something you will get absorbed in pyrogalol. As per balanced reaction, initially if there were X plus Y by 4 moles of O2, then there will be no moles of O2 after reaction because all the moles will be consumed. And we will get X moles now of carbon dioxide. So that's the balanced reaction we will use. Now, contraction in volume on explosion and cooling. Explosion will give this reaction, will start this reaction, and cooling will make these vapors liquid. Okay? So that's why L is written here. So this will become liquid. So this will not contribute to any volume. So it will not contribute to any volume. So contraction in volume will be, what is the initial volume? And initial volume is this much. If oxygen is there, so you can add oxygen also. Okay. So say oxygen is Z, add here. And minus whatever is after. Here also you will add Z because after that also unused oxygen will be there. Okay. So in that case, Z and Z will get cancelled. Plus Z minus Z will get cancelled. You will get same thing. So initially the volume was 1 plus X plus Y by 4. After reaction, the volume was just 0 plus 0 plus X, that is X. So contraction in volume will be initial minus final. 1 plus y by 4. It is important because we will be using it in finding the answer. Contraction in volume is 1 plus y by 4. Now the question. Okay. And we will be using this concept. Okay. Either we will be using two. We can use it in two different forms. Either we will be using that how much oxygen it reacted with, or we will be using that what is the contraction in volume. How? This is the question. Okay. 8 milliliters of a gaseous hydrocarbon was exploded with 45 milliliters of oxygen. Read the question carefully because otherwise you will not be able to understand what I am going to explain. Okay. 8 milliliters of gaseous hydrocarbon. So gaseous hydrocarbon means CXHY was exploded means reacted with 45 milliliter of oxygen. The volume of gases on cooling was found to be 37 milliliter, 16 milliliter of which was absorbed by KOH. Now, who will tell me what information you get from here? The encircled part. Raise your hand. Which information you get from here? 16 milliliter of which was absorbed by KOH. Okay. I will give chance to Yash Bedi. Yes, Yash.
And I'm audible.
Yes, you are audible.
And I think 16 ml of CO2 is absorbed.
Right. So whatever amount is absorbed by KOH, that is the amount of carbon dioxide. But remember, the question says that total volume was 37. After explosion, total volume was 37. Out of which 16 ml was absorbed, means if you had CO2 plus O2, and remember we are talking about cooling, it means H2O is not there, that has been liquefied. So we can have CO2 plus O2 plus some other gas, might be. So this may or may not be there, but this will certainly be there. Unused O2 will be there. That's why it was 37. Otherwise it would have been only 16 ml. Why? Because if you see this reaction, after reaction, this will get cooled. It will not occupy any volume. Whatever volume will be there will be due to this one. So because the volume was greater than, out of which some was absorbed by KOH, it means the rest is oxygen. Okay. Because it is written the rest was absorbed in alkaline solution of pyrogalol, it means rest was oxygen. Any confusion here? Let me know.
No,
Okay.
sir.
Good. If all volumes are measured under same conditions, deduce the formula of the hydrocarbon. So find the formula of the hydrocarbon if temperature and pressure remains same. Now understand it. And we are going to make use of this thing. Okay. We are going to make use of this thing. What is here? Here it is written that you have 8 milliliters. I think it was 8. Just a second. 8 milliliter of gaseous hydrocarbon and 45 milliliter of oxygen 37 mixture. Okay. So 8 milliliter reacted with 45 milliliter. These were 0. Okay. This was 0 initial. Now 45 milliliter, it means some oxygen remain unreacted because there was some oxygen also which was absorbed by the pyrogalol. It means not completely 45 ml was reacted. Okay. So contraction in volume, what will be the contraction in volume? 1 plus y by 4. This is the contraction in volume. Okay. So what will be the contraction in volume in this case? In this case, contraction in volume will be whatever volume was initially 8 ml plus 45 ml, and what was the volume after 37 ml. Am I clear or not what I am saying? Initial volume, this is before reaction, Before reaction, the volume of the compounds, everything, whatever you had, hydrocarbon plus oxygen, was 8 ml plus 45 ml. After the reaction, it is given the volume is 37. Total volume is 37, and it was written that out of which 16 ml was absorbed by KOH. Do you remember that in the question it was given? It means what is the contraction? This contraction is before is 8 plus 45, and after was 37. This should be equal to 1 plus y by 4. Am I clear or not what I am saying? Or if there is any confusion,
sir.
let me know.
Yes, sir.
Okay. So by formula, we know that contraction in volume is 1 plus y by 4 according to this balanced reaction. But according to question, the contraction in volume is 8 plus 45 minus 37, which will give you how much? 85 plus 53, 16. So contraction in volume is 16, and which is 1 by, and by formula it is 1 plus y by 4. But there is something you need to focus here. Just look onto the question, read the question before I tell you. And I'm writing the balanced reaction also, just a second, so that you can understand what I'm going to talk about. This is 8 ml. This is 45 ml. Here it is produced 16 ml. Now remember, what is the ratio? The ratio is that here it is 1 written. 1 mole of hydrocarbon produces X moles of carbon dioxide. 1 mole of hydrocarbon produces X moles of carbon dioxide. From here, what information do you get? It means 8 ml of, we are talking about volume, okay, which is same as moles. So volume and mole ratios are same. 8 ml will produce 8x milliliter of CO2. Is this clear or not what I am saying? 1 milliliter, 1 mole will produce X mole, or you say 1 milliliter will produce X milliliters of carbon dioxide. It means whatever we have 8 milliliter will produce 8 into X milliliters of carbon dioxide. Is this clear or not?
Yes, sir.
I'm applying simple stoichiometric relationship. What is that? That if A plus B gives you XC plus something, okay, plus D, say, it means 1 mole of this gives X moles of this one, 8 mole will give 8X moles. That's what is the logic I am applying here. Okay, just a second. Yes, Vijayant. Yes. Yeah, that's fine. That's fine. That's fine. Fine. Okay. So this is the concept I have applied here. Okay. If 1 ml produces X ml, 8 ml will produce 8X ml. And this 8X is equal to 16 milliliter. This is given in the question. CO2 is 16 milliliter. So you got the value of X of the hydrocarbon. You have to get hydrocarbon, okay? Deduce the formula of hydrocarbon. That's what you have to obtain. And this is how you will get the value of X. It means when you equate 8X to 16 ml, you got X equals to 2. Any confusion here? Let me know if you are not clear about it. Clear? Good. Now the next part, contraction in volume. I am writing again the same equation. Okay, CXHY plus X plus Y by 4 O2, not H2O. O2 gives you XCO2 plus Y by 2 H2O. Okay. Now contraction in volume. Contraction in volume for 1 mole was X plus Y by 4. Sorry, 1 plus Y by 4. 5. Contraction in volume, if you see here, contraction in volume is this much for how many moles? 1 mole or 1 milliliter. So this reaction is about 1 milliliter if you apply. So for 1 milliliter, contraction in volume is 1 plus Y by 4. For 8 milliliter, what will be the contraction in volume? It will be 8 times 1 plus Y by 4. So contraction in volume for 1 ml 1 plus Y by 4, contraction in volume for 8 milliliter of hydrocarbon will be equal to 8 times 1 plus Y by 4. Am I clear or not? Any confusion?
No, sir.
And this contraction in volume we have already calculated. Initial volume was 8 plus 45, that is 53. And final volume 37, contraction in volume was 16. So this is again equal to 16. Contraction in volume means 1 plus Y by 4 equals to 16 by 8, 2. Y by 4 equals to 2 minus 1, that is 1. Y equals to 4. So we got X equals to 2 and Y equals to 4. It means the hydrocarbon is C2H4.